right, let's graph parent functions and translations. If we look at this equation, this is a quadratic function. The reason I know it's a quadratic function is because of this 2 right here. And that's going to make the U-shaped graph. As long as you know what your parent function looks like, you can graph pretty easily with translations. If you can't remember all of your points, you can do a table of values. I'm going to show you a few how you could do a table of values to set the shape of the graph. You get to choose the x values that go into the function. You can square any number. Squaring means multiply it by itself. -2 squared is 4. -1 times -1 is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. That's what we call a parent function, the very basic function without any numbers, without any translations. This looks like a U-shaped graph. And now we're going to translate it. For translations, anything with the x moves left or right, but it's opposite of that sign. Since that says minus, we're moving right. Anything outside the function after the symbols goes up or down. Plus is up. So take the vertex of the parent function and move it right 2 and up 3. Every point moves right 2 and up 3. You can move all of them or just enough to get the general shape of the graph. Now to find the domain and range of the new function, domain would be your x's. What kinds of x's can go into this function? Anything. So you can write that fancy r, or you can write -infinity to infinity. That's interval notation. For range, that would be your y values. The lowest y value to the highest y value. In this case, 3 with the bracket, meaning it's included, and infinity. Infinity always has a parentheses with your domain and range. Let's look at a few more quickly to get you an idea of how to graph a variety of parent functions and refresh your memory. This parent function is the cubic function. If I want to do a table of values, I can. I can plug in as many numbers as I need to, or as little, just something to help me remember what the shape of the graph looks like. The parent function's cubic, so that means I am going to cube every number here, -2, multiplied by itself 3 times. -2 times -2 times -2 is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. This is what the graph looks like. It's the parent function. And it is hard to graph, those parent functions with that many points. I accidentally put the dot here, so let me move it. It should be on 2. And it's going to be pretty hard to graph and catch those points, but you can sketch it, or you can just try to graph the first 3 that's in the middle and know the shape of the graph. This is outside the function. It's not in parentheses, so that means the graph's going to go up 3. So every point goes up 3. And now you can see why we just do those 3 points in the middle and just know the shape of the graph, because it's a little bit easier to graph that way. And the domain for these would be all real numbers, and the range is also all real numbers because it goes up and down forever. All right, let's look at a few more graphs. This is the absolute value function. If you need to do a table of values, you can look at any values you want to. The shape of the graph looks like a V. Absolute value means you make the values positive. The y's are going to be positive. That's the only thing that changes. Positive numbers stay positive. Negative numbers go to a positive value. All right, so that is a V. with this translation, you're going to reflect over the x-axis. That's a reflection, that's up and down. And you move left 3. So reflects means it points down. And the vertex moves left 3. So I'm going to take that vertex and move left 3. And just make sure the graph points down instead of up. It reflects over that x-axis. All right, so let's quickly look at a few more, just so that you get an idea of what this does. Identify your parent function, do a little table of values. This parent function is just the square root of x. Think about what you can take the square root of, because you can't take the square root of negative numbers. You can take the square root of 0, 1, and 4. And that will be my parent function. A parent function is the basic function without any translation, without any numbers with it. This graph moves right 1 inside and down 4. That's outside. So the graph, I start with the little point at the beginning, right 1 and down 4. Every single point moves right 1 and down 4. Right 1 and down 4. And then that would be your hook there. The domain for this starts at 1 to infinity, and the range is -4 to infinity. Remember, domain's x, range is y. Okay, our last one is our cube root function. So to graph the cube root function, all you have to do is switch the x and y's, because now you have to think, what can I take the cube root of? So if you think of the cube graph and just switch your x and y's, that would work. We don't need that 2 right there. So the cube root of -8 is -2. The cube root of -1 is -1. The cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. So we can see that this graph is kind of turned on its side. It's long ways. This is the cube root graph. It's a little hard to draw as well, so sometimes I just look at the 3 in the middle and then just know the shape of the graph goes to its side. And then we're going to graph using a translation. This is inside, so that means you move right 4. Anything inside that function moves left or right, but it's going to be opposite of what's inside that function. So minus goes right, plus goes left. So I have to curve it to the left even though it moved right 4. And it is gradually going up and down forever as it goes left and right. So that means that domain's all real numbers and the range is all real numbers. Right, so study your parent functions. If you know what those look like, then you can graph a variety of functions just by using translations.